Hey everyone, and welcome. If you've got an exam on ecosystems coming up, you are in the perfect spot. We are going to blitz through all the key stuff you need to know in the next 5 minutes. All right, let's kick things off with a bit of a riddle. What in the world connects a lion, a mushroom, and the sun? I know, it sounds like the start of a really weird joke, right? But stick with me, because by the end of this, the answer is going to make perfect sense. So here's our game plan. We're going to hit the basics, meet the key players in their relationships, follow the energy, check out what happens when ecosystems are under pressure, and then wrap it all up with a super quick summary. You ready? Let's do this. Okay, first up, Section 1, the basics. We're going to start with the big picture. Right. Let's get the most important question out of the way first. What exactly is an ecosystem? Okay, so simply put, an ecosystem is a community of living organisms interacting with all the non-living stuff around them. The two magic words you gotta remember are biotic, that's all the living things, plants, animals, fungi, and physical, which is the non-living stuff like the sun, water, rocks, and temperature. It's really all about how those two things connect and work together. All right, that leads us perfectly into Section 2, key players and relationships. So we know what an ecosystem is, now let's figure out who lives there and how they all get along. Think about it like this. In any ecosystem, every single living thing has a job to do, and we can basically sort them into three essential roles. So what are they? You've got your producers, your consumers, and your decomposers. Producers are kind of like the chefs of the ecosystem. Think plants, using sunlight to cook up their own food. Then you have the consumers. They're the customers, getting their energy by eating other things. And finally, the decomposers. These guys are the cleanup crew, the ultimate recyclers. They break down all the dead material and get those valuable nutrients back into the system.
So none of these guys live in a bubble, right? They're constantly interacting. But what do those interactions, those relationships, actually look like?
Okay, let's break down the main types. First, you have the classic predator-prey relationship. Pretty straightforward, right? The predator benefits and the prey, well, not so much. Then there's mutualism. This is the win-win scenario where both sides get something awesome out of the deal. And finally, you've got parasitism, where one organism, the parasite, benefits by living on or in a host, which gets harmed in the process. Think of a flea on a dog, a total freeloader. Okay, moving on to Section 3. This is where it all comes together. We're going to follow the energy. And where does it all begin? Yep, the sun. Now, you've definitely heard of food chains and food webs. A food chain is super simple. It's just a straight line showing who eats who. But let's be real, nature is way more complicated than that. That's where the food web comes in. It's basically a bunch of food chains all tangled up together, showing how everything is interconnected. It looks more complex for sure, but it's a much more realistic picture of what's actually happening out there. Okay, here's a big one. This pops up on exams all the time. We know energy flows up the food chain, but here's the tricky part. Why does the amount of available energy go down at each step? Let's walk through it. Imagine a carrot, then a rabbit that eats the carrot, and a fox that eats the rabbit. So let's say our producer, the carrot, has 10,000 kilojoules of energy locked inside it. Now, when a rabbit, our primary consumer, comes along and eats it, you'd think it gets all that energy, right? Nope, it only gets about 1,000 kilojoules. And then when the fox, the secondary consumer, eats the rabbit, it gets even less, just 100 kilojoules. So what is going on? Where did 90% of the energy disappear at each step? Well, here's the key. Only about 10% of energy actually gets passed on. The other 90%? It gets used by the organism just to live, for moving, breathing, keeping warm, and a lot of it is lost as heat. This is a huge deal, and it's why you have way fewer predators at the top of a food web than you have producers at the bottom. And that idea of connection brings us right to Section 4, ecosystems under pressure. Because if everything is so interconnected, what happens when you pull on just one single thread? Okay, let's play a what-if game. Let's imagine our cleanup crew, the decomposers, just disappeared. Poof! All the bacteria, all the fungi, gone. What happens next? Honestly, it'd be a total disaster. Without them, all those vital nutrients would just stay locked up in dead stuff. Nothing would rot. The producers, the plants, would eventually run out of nutrients in the soil. And if they die, well, the entire food web just collapses. It shows you just how incredibly important those decomposers really are. All right, let's move from a thought experiment to a real-world example. You've got these birds called red-billed oxpeckers.
They have a mutualistic relationship with impalas. They eat the ticks off them. So what happens if the oxpecker population suddenly plummets?
You get this amazing chain reaction, a ripple effect. Step 1. With fewer predators around, the tick population would just explode. Step 2. With way more ticks, the impalas start to really suffer from all those parasites. Step 3. The health of the impala population starts to decline. It's a perfect example of how changing just one piece can mess with the entire puzzle.
Phew. Okay, we've covered a ton of ground. Let's do a super fast recap to lock it all in. This is Section 5, your final revision summary. These are the absolute key things to remember.
Okay, here we go. 1. Ecosystems are all about the living things interacting with the non-living environment. 2. Energy flows in one direction, from producers to consumers to decomposers. 3. Food webs show us that everything is connected. 4. The big one, only about 10% of energy makes it to the next level. And 5. Because of all that, changing just one population can have a huge effect on the entire ecosystem.
And there you have it, your 5-minute ecosystem revision. And now you know the answer to our riddle, right? The sun is the original source of energy, the lion is a consumer, and the mushroom is a decomposer, all key players in the same game. So, I'll leave you with a final thought to chew on. If every ecosystem really is this delicate, interconnected web, which single thread do you think is the most important one to protect? Thanks so much for tuning in, and best of luck with your revision.